Happy morning, dear friends. Here's Dr. Rajanta. Welcome to Demystify with Ajay. In today's episode of One Concept 2 Minutes, we are diving deep into regularization. There was a time when my desk looked like a war zone. Tangled wires, stacked books, gadgets I had not touched in months, sticky notes everywhere. I told myself it was all important, but deep down I was just overwhelmed. Then one weekend, I cleared it all. I threw out what I didn't need, bought the rarely used stuff, and kept only the essential. A clean laptop, a notebook, one pen. The result, of course, the desk felt lighter, my mind felt sharp. That moment of clarity, that's exactly what regularization brings to machine learning model. It fights the clutter, it reduces the noise, it forces the model to focus on what really matters. Dear friends, in machine learning, regularization is like decluttering the model. When your model starts fitting every tiny fluctuation in the training data, even the noise that called overfitting, it performs greater on the training set but poorly on new unseen data. Why? Because it became too complex, too sensitivity, memorizing instead of learning. Regularization adds discipline. It modifies the loss function by adding a penalty term for large weights, telling the model don't rely too heavily on any single feature. And difference, there are two types of regularization. L1 regularization, also known as lasso. It adds the absolute value of each weight to the loss function. This has a special property. It can shrink some weights exactly to zero. In fact, it removes unnecessarily features. It's like saying you are not useful, out you go. So L1 is great when you want a sparse model, one that selects only the most relevant inputs. L2 regularization, also known as ridge. It adds the squared value of each weight to the loss. Unlike L1, it rarely makes weights zero. Instead, it gently nudges all of them to be smaller, discouraging extreme values. It just says, don't rely too much on any single input. Let's keep things balanced. So L2 is ideal when you want a smooth, stable model where even future contributes little. Sometimes we even combine both in what called elastic net, getting the sparsity of L1 and the stability of L2. Yes, dear friends, we often think more in better, more feature, more parameters, more complexity. But in the real world and in machine learning, less is often more. Regularization helps the model let go of the noise and hold on to the essentials. Because whether it's your desk or your algorithm, clarity comes not from adding but from subtracting wisely. Thanks for watching. If you found this helpful, don't forget to like, share and subscribe for more quick and clear lessons on AI and machine learning. See you in the next one.